All right, let's go ahead and practice some more balancing. So what we're going to do is we're going to redo these two problems, even though we've already done them, just to sort of refresh our memory. And then we're going to look at a little bit more complex problems, but they're not really that bad. All right, so if you take a look, again, there's one magnesium, so that's good. Two manganese, one manganese. And so what you have to do, the only thing you can do is put large whole numbers in the front that multiply what you have. And so you put a 2 there, and it multiplies that and gives us 2. 3 oxygen, 1 oxygen. Again, all you can do is put large numbers in the front that multiply it. So we put a 3 here to multiply the oxygen. And when we do that, that gives us 3 oxygen on the left and the right. However, this 3 also multiplies the magnesium. And before the magnesiums were balanced, but now they're not, but that's okay. Sometimes it happens, and you just have to go back and balance it. And the way you do that is by putting a 3 here, and now it's all balanced. So again, all you do is you put large numbers in the front that multiply, they give us the correct number. Easy peasy. 1 zinc, 1 zinc. 1 hydrogen, 2 hydrogens. Okay, so we got to multiply this by 2. But when we do that, that also multiplies the chlorine by 2. And oh, look, there happens to be 2 chlorines over there. And so for this particular one, the only thing you need to balance is by putting a 2 here. So this is a review from last time we did these practice problems. Let's go ahead and take a look at a couple of more challenging problems. And what I'm going to do is I'm actually going to start with the middle one first. Okay, so I'm going to start with the middle one first. And what's different about these problems is that they actually contain polyatomic ions in them. And so when there's polyatomic ions, you can actually treat those polyatomic ions as one unit. And so let me go ahead and explain that. This right here is PO4, and instead of breaking up the phosphorus in the oxygen, notice how there's PO4 on the left and there's PO4 on the right. So notice how we have PO4 on both sides. And so we can treat that as one unit. Instead of just counting the phosphorus and the oxygen separately, we can count the PO4 as one unit. And so what I'm going to do is I'm actually going to write PO4 on the bottom here. How many PO4s are on the left? There happens to be 2 PO4s on the left. Now, how many PO4s are on the right? And I want you to actually answer this question, because if you make the mistake now, you won't make it later. There is a common mistake that people say in this for this when I ask, how many PO4s are over there? And the answer is 1. There's 1 PO4. The mistake that people make is they say 4. But remember that 4 is a part of the PO4. If there was 4 over there, this would be in parentheses and there'd be a 4 there. But because it's not in parentheses, that means that it's 1. So there's 2 PO4s on the left and there's 1 PO4 on the right. And so that tells us that we need to fix that by multiplying this by 2. And when we multiply that by 2, this becomes 2. But what about the irons? Well, the irons, there's 2 irons here now, because we put that 2 there, it multiplies that iron, but there's only 1 iron over here. And so we have to put a 2 here to fix the irons. But when we put a 2 here, it also multiplies the chlorine. And notice how we now have a total of 6 chlorines right there, because there's 3 within the formula, and that 2 multiplies everything it's in front of, so there's 6. So how do we get 6 right there? Well, again, there's 2 here, so what do we need to multiply it by to give us 6? We need to multiply it by 3. When you multiply it by 3, that's going to give you 6 chlorines. And this here also gives us 3 berylliums. When we put a 3 there, it doesn't just multiply the chlorine, it also multiplies the beryllium. But notice how we have 3 berylliums on the left already, and so that actually fixes the beryllium, and now this is balanced. Again, if there's nothing there, we assume there's a 1. The big difference here is that we're dealing with polyatomic ions. If you have a polyatomic ion on the left and the right, you can treat it as one unit, but again, it has to be both on the left and the right. So let's go ahead and take a look here. Is there any polyatomic ion in this? And the answer is yes, there's actually 2. There's nitrate, NO3. Notice how we have NO3 there and we have NO3 there. We also have hydroxide, which is OH. And so we can treat those again as one unit. All right, so one silver, one silver. Notice how NO3 is here, and we have one NO3. Again, that 3 is a part of NO3. And we have one NO3 over there, so that's good. Lithium, lithium. So we have one lithium on the left and one lithium on the right. And then OH and OH. We have one on the left and one on the right. And so this actually is already balanced. This is already balanced. And so this is 1, 1, 1, 1. And so in this situation, they're balanced. So that actually works out. And again, you don't have to write the ones. All right, let's go ahead and do this last one. This last one, if you take a look, we have OH right here, which is hydroxide. So that is a polyatomic ion. But do you see the OH over here? And the answer is no. Because it's not on both sides, that means you cannot treat it as one unit. You have to treat it as two units. But what about this one? This is SO3 and SO3. So we do have SO3 on both sides, so we can treat that as one unit. So let's go ahead and go through this. How many bariums are on the left? There's one. How many bariums on the right? There's one. How many hydrogens are there on the left? And I want you to actually pause the video and answer this, because there's going to be a lot of mistakes with this one. How many hydrogens are on the left? The answer is, I'll write it here. The answer is there's 4 hydrogens on the left. So how is there 4 hydrogens on the left? Well, first off, we have 2 right there. Secondly, this 2 multiplies everything that's in the parentheses. And because we can't treat this as one unit, we have to count the hydrogens and oxygen separately. And the reason why we cannot treat it as one unit is because it does not appear on both sides. There's no OH over here. And so this 2 means there's 2 right there. Over here, there's 2. And so what we have to do is put a 2 here to multiply the hydrogens to give us 4. However, when you do that, notice how that also gives us 2 oxygens. And how many oxygens are on the left? Well, what I'll say is, we don't count this oxygen here. We don't count this because we treat the SO3 as a single unit. So because we treat these as a single unit, we don't include the oxygen when we're counting the other oxygens. And so there's 2 oxygens here now because there's 1 in the formula, but we put a 2 here that multiplies it. And if you take a look, there's 2 oxygens here because that 2 multiplies everything that's inside the parentheses. And so that actually is balanced now. This equation is balanced because we have 2 oxygens on the left and 2 oxygens on the right. We have 4 hydrogens over here. We have 4 hydrogens over here. We have 1 barium, 1 barium. We have 1 sulfite, SO3 sulfite, and 1 SO3 over there. So this is now balanced. The only thing you need to do is put a 2 there to balance it. And let's go ahead and look at our last 2 problems here. So these are combustion reactions. We'll talk about what combustion reactions are later. But this is essentially carbon, hydrogen, and oxygen. And so these are called CHO reactions because it's CHO. And so when you are balancing combustion reactions, you always save the oxygen for last. This is definitely one in where you save the oxygen for last. So if you take a look, there's 4 carbons here. There's 1 carbon there. So we multiply this by 4. There's 8 hydrogens here. There's 2 hydrogens there. So we multiply this by 4. Because again, there's 2 hydrogens. There's 8. 4 times 2 is 8. How many oxygens are on the left? Well, I'll go ahead and tell you. Look, if you take a look there, there's 2 oxygens on the left. How many are on the right, though? So pause the video and answer this, because again, this is one that people make mistakes. So I want you to actually pause the video and answer this. How many oxygens are on the right? The answer is 12. there's 12 oxygens on the right. And if you don't see where they are, I want you to pause the video real quick, and I want you to see where they are on your own. Because if you can find it out on your own, you're going to understand it a lot better. So the reason why there's 12 on the right is because look right here. How many are right here? Well, 4 times 2 is 8. But there's also 4 oxygens there, which gives us a total of 12 oxygens. So what do we need to do? We need to multiply this by 6. And when we do that, that actually balances it. Now something I want to point out is if you need to do this, if you need to write it out to where you're writing on each side, definitely do that. I'm kind of doing a combination. I will tell you, I personally never do this, and I really believe you can get to the point where you just look at it and you can do it on your own. If you cannot do that though, that's totally fine. That's okay. You can write it out. You can write it out like this and count them. So you do whatever you're comfortable with. All right, again, this is combustion. We save the oxygen for last. And in this one, I'm not going to, or no, I'll go ahead and write it out on this one. So if you need to actually write them out, go ahead and do that. If you don't need to write it out, then you don't have to. All right, carbon, there's 2 carbons over here. There's 1 carbon here. There's 4 hydrogens, there's 2 hydrogens, there's 2 oxygens, and then there's 3 oxygens. Because there's 2 here, 1 there, makes 3. All right, we do the carbons first. This makes this become a 2. We do the hydrogens next. Oops. However, notice how this 2 and this 2 don't only multiply the carbon and the hydrogen, they also multiply the oxygen. And so we don't have 3 oxygens anymore, but rather we have 6. Because again, if you take a look, there's 4 here, there's 2 there. That's going to give us 6. So how you fix that is by putting a 3 there, gives you 6, and now it's balanced. I want to erase these. All right, and it's that simple. All right, so I know that again this takes a little bit of practice. It's not too bad though. Once you put the practice in, it's really not that bad. You're just counting how many are on the left and how many are on the right, and putting coefficients in the front that multiply them to give us the correct amount. If something is unbalanced, that means it's not satisfying the law of the conservation of mass. But once you balance it, it is satisfying the law of the conservation of mass. And that's it. So go ahead and come to class with questions, and have a great day.